joining. Okay, so getting started here, got a couple things on the agenda for today. Talk about functions, and then hopefully we'll have time to talk about strings as well. There might be some more people joining us. I know there's some bad weather moving across Indiana. Oh, there's Nia. Let him in. Hi, Nia. We were just getting started. Yeah, so today seems like a good time to point out. I know there's some bad weather moving across Indiana today, so some people might have power issues. And as we get into spring and warmer weather, thunderstorms are going to pop up. So, well, afternoon thunderstorms are going to pop up, and we have an afternoon class. So at times that might affect us. If at any time my power gets cut off and I get kicked off the meeting, I always have my phone in my pocket. So within a few seconds, as quickly as I can pull it out and hit all the buttons, I will log back on from my phone if I lose power or anything in a storm. It'll probably, if I get kicked off, it'll default and try to make somebody else the host. But I always make sure my phone is fully charged before the meeting so that if I get kicked off, I'll be back on in just a couple of seconds time. Oh, looks like the sun's coming out now though. I didn't really expect that this afternoon. So I just wanted to make the weather note because it's the season for thunderstorms, which can often lead to power outages. Let's see. So the extra credit assignment I mentioned the other day is up and ready. I sent out an announcement about that. It's kind of an important skill, being able to parse through strings, but this particular week, I'm more worried about you spending your time on I'd rather you spend your time on the project proposal than the regular programming thing. So I decided to make that an extra credit assignment. So what was intended to be the string portion has been moved to extra credit. I put it in module 3. I think I called it post module 3, but after we pass module 3, you might not look at that again. So just remember that it's there on the assignments page. And as an extra credit thing, you have to the end of the semester to do that. But remember, when we get to databases here in a couple of weeks, a lot of times our results will be coming back in the form of strings. So you might want to get a little bit of practice at parsing through strings before we get to databases. But as time allows, I know everybody has a very busy schedule, so that's on there and ready. Last night I was I found an hour or so and sat down and was messing around with Lucid Chart and in particular team functionality there. So y'all probably received a bunch of emails about shared documents on Lucid Chart. It's just some like scheduling things, and I was really just playing around with it, learning where the buttons were, the different functionality. But there is a folder that has our class name that I shared with everybody. So in that folder, we should have access to the files, each other's files. And one person tried to upload the wireframe through that Lucid Chart and Canvas integration thing and was getting that same error message I got. So he ended up just sending me a share link. So that works too. If you do your stuff on Lucid Chart and not able to get that integration to work correctly, there's a share button on the diagram. So you can just share the diagram with me or do the normal export it as a image or PDF or something and submit that. Any way you can get the diagram to me really works. I was anxious to try that stuff. And that's what all those emails last night were about. I found an hour or so to kind of mess around with it and try to learn a little bit more about it myself. And I was working with some of the team functionality and different things. And a whole lot of the stuff I did last night, I just shared with the whole class here. I think y'all's emails were all on the clipboard the whole time. So every time I'd get to something different, I'd just paste all of them in the share option. So you probably got emails from all of them. What else did I have? Oh, on the chapter 19 exercises, we went a little bit out of order because I wanted to include dates pretty quickly. I might write it on the board when we get over there. There's a list of 8 things that I always try to learn as quickly as possible when getting to a new programming language. Like obviously, the variables, the basic syntax stuff, like the syntax for if-else blocks and while loops, and the basic syntax, how to do variables, how to do functions. There's a few things I'll write the list on the board at some point, but dates are one of the things I always include on that list to try to learn as quickly as possible. Just 8 things. So I wanted to go ahead and do the chapter that covered dates, and I did not think about how, with the organization of the textbook, the date chapter comes after the SQL chapter, or chapters on SQL and relational databases. So one of the questions on that chapter 19 exercises was a SQL. It was looking for the structured query language answer. So number 5 on there, obviously give it a try, because the database class was supposed to be a prereq for this. So you should have seen that somewhere before, but everybody's automatically going to get the 2 points on number 5 there because we haven't covered SQL in class yet. But there was a question on it, but it should have been a prereq, so everybody should be kind of know what to do on it. But yeah, that's why I threw that in there, because dates and timestamps are one of the things I feel is somewhat important. It's very straightforward. The book had it all. I was going to briefly mention it in lectures, but since we might be running a little bit low on time, the book covered it pretty well. So the one main point I have about dates with server-side scripting, or, well, really considering entire website, the full stack type development, the one thing I'd note, typically I do dates on the client side. Dates and times, if you do that in the JavaScript on the client side, it's going to run on that local machine. So people will always be looking at their own time. With servers, there's a really good chance that the server the PHP script is running on is not going to be in the same time zone as the person looking at it.
So it's like the one on Becky's thing, that when I pull that up, I said when they do the thing, God knows, I think it's Greenwich Mean Time that it's actually coming off of.
Yeah, a lot of them just default to that. But yeah, I find it easier just to do it in JavaScript, and I kind of still put it in the PHP. I echo back a script tag with pulling up the date and with the JavaScript instructions to pull up a date, echoed from the PHPs, but it's actually in the client-side language. That way, it's always the date and time of the machine it's running on, so people aren't going to get confused and wonder why the time seems really weird. But it is an important thing to learn. So there's Blake. We might talk about dates some, but the book was pretty thorough on that. And the only thing is, that question number 5 was a SQL question, which everybody should have seen before, but we haven't covered it, so everybody's not automatically going to get the 2 points there. Just give it a try. And I was working around with that lucid chart stuff last night. I have about an hour to play around with it. Like I mentioned, y'all probably got those emails, the invitations for shared documents or whatever. If you want to give that a try. If anybody would like to go over using that sort of software in more detail, let me know, and I can put something together, sort of a planned out thing. Is those schematic creation softwares, it's not like normal drawing software, as you're probably well aware. It's actually categorized under CAD stuff, and y'all probably haven't had any actual training in CAD, so we have to approach it a little bit differently. If anybody would like to kind of take a few minutes and go over that sort of software sometime, let me know, and I will get something, put at least a quick version together to go over things. Because it is something we do often need diagrams to represent things. Humans are a visual species, so when we can put it in a picture is worth 1,000 words. There's a lot of truth to that old saying. I'll do that when we get to the example. There was I noticed in the homework it showed up, there was an error message, a very, very common error message that is probably also one of the most vague error messages and hard to make sense of when we see it. But it's a very common one, and I probably should have thrown that intentionally in class so that y'all would know how to recognize it. I saw it on the homework, so I will, whenever we get to examples here shortly, I will make sure and throw what's probably the most common, one of the 3 most common errors to happen, because the message for it is completely useless as far as tracking down the problem. So does anybody have any questions before we get started into today's stuff? Okay, I assume the silence means no questions. So next thing on the agenda for us is functions. And I guess leading into this, often when we program our scripts, we end up doing the same or very similar things over and over and over again, right? In the weekly programming assignment, I worked that in on purpose to make sure we had something to clean up, like all those checkboxes. The requirements had you put 6 checkboxes there on the form, and all of them process in a very, very similar fashion. We have that whole generic part that's going to be the same, like if, is set, and we either send in it through post or get, probably post. I'll just write get this time to change it up a little. And whatever goes in here changes. So I'll leave that blank. Then what goes in our line, that's going to change. And all the if-else syntax. So that's different, and that's different. But there's fewer differences than what's similar, right? Every single one of them says if, is set, has all those parentheses, post or get, curly braces, semicolons, all of that's the same. So there's fewer differences than there are similarities for it. That sort of thing happens all the time when coding. I picked up that eraser and it looked covered in chalk. So that is something we don't necessarily have to write that similar stuff every time. We can save a lot of work and cut down on chances of making a typo by putting those similarities in there once and then only changing the different, only making changes to those few differences. So reusable modules of code. And that's our typical verb for this. It doesn't show up in casual conversation a lot, but in textbooks, that's the technical term for it, is modularizing our code. We break it up into separate modules, and typically they're not independent enough to be a full script on their own. Sort of a single task. That's the ideal you want to look for, is each one of our functions will carry out a single task. And that way we can reuse that over and over and over again. Even if it doesn't need reused, it also leads to an organization thing. It leads to some highly organized code, and having the code very well organized makes it a whole lot easier to debug when problems happen. Because then instead of digging through that whole big mess of a script, we can go right to the module that we think the problem would have arisen from, and single out errors. Or in the long run, when it comes time to update a script, or to update our software, we don't have to dig through and redo the whole thing and worry about the interactions. We can just go to that particular module that's getting updated and leave the ones that aren't being changed like they were. So it makes there's an organization aspect that comes with it as well, even if we're not reusing, even if we're not taking advantage of the reusable aspect, especially when debugging and updating. The updating doesn't really show up in the classroom much because we're very restricted on time in a classroom, but in the real world, the updating happens a lot. There's more updating than creating new things after you finish all the classroom stuff. And once a function has been created, it can be used over and over again, not just by us, by anybody. We write a text file, and if we want to encrypt that and store it someplace where nobody else can get it, that's fine. But we could make that available to anybody that wants to use it, and then they don't have to write that function. They can just use the one we wrote. This is that's where a lot of the appeal in PHP came from. You might remember back on day one when we quickly went over the history. For the first 20 years of PHP, there was no formal standard. So it was just programmers around the world, a bunch of programmers that knew C++ and expanded it to this little modification of interpreted C++ that we call PHP. They just kept building functions. Thousands of programmers building functions for 20 years. So 20 years of programmers just adding functions before there was an official standard. And we ended up with thousands and thousands and thousands of libraries filled with functions. The official library, then they went through and selected a whole lot of really good ones for the official standard format. The official library has thousands and thousands and thousands, but we can import any other library any other PHP function that's been written and use those. So there's, it'd be hard to even really imagine. I'm going to say thousands and thousands and thousands, but I'm sure it's millions if we really dug down into it. Now it's up to 30 years of programmers adding functions, and there's a lot of programmers in the world that have added that. So as a result of this, the one thing that's really nice about PHP is there is a very, very high probability that whatever you want to do, there's already a function that does it. So theoretically, you probably never have to write a function. But we're in a classroom setting, so a classroom definitely requires us to learn how to write functions, right? So definitely required in a classroom, but theoretically, just about anything you ever need to do with your PHP function, there's a very, very, very high chance that there's already a function that does it. But we need to learn how to do this. And for organizational reasons, keeping things nice and neat, we typically put functions in an outside file in PHP. That's not a hard requirement, and there's been many times where I had a very specific function that I knew wasn't going to be used elsewhere that I would just throw in that script. But y'all have seen it with PHP scripts now. We're already mixing a couple languages, right? We have at least the HTML and the PHP intermingled, and in a lot of cases, you can probably visualize this even if it hasn't shown up in your work yet. There's going to be times where we need to throw in a style tag and throw in some custom CSS in the page to override the general site settings. Or we might need a little bit of client-side scripting once we get our data back. So we throw in a script tag and put in that JavaScript. So we're already mixing a lot of languages. I think that's probably why we typically put them elsewhere. It's not a hard, fast rule, but most people do this. And it also allows us to import it, because if it's wrote in another file where the stuff's not going to run on its own, it's there to be reused over and over and over again, not just in the current project. Typically, put PHP functions in, I'll put separate file. I haven't compared to the old videos. I think my handwriting is getting better as I slow down and try to actually focus on that. But this means we have to import it. Means we have to import into our script, the one we're actually working on, where we actually want that function to run. Because the separate file, I'll put in parentheses here, a library. For those of you all who have had some Python or are currently in that Python class, the intro class that uses Python, Python calls those modules, where we just have a file full of functions, but we never actually start them in that file. We just define all of them in one file and then import them to the one we're going to use. So in the C family, we usually refer to those as libraries. So we define the function, but we never actually run it in that file. In order, the script we actually want to run it in, we have to import. And to import it, there's two ways. We either use the word require, I need require, and I'll put, I'll write library name .php. Trying to write neater still. Library name .php, and actually bring that in. The rest of the ones I'm just going to write ... but something like that. So we require the PHP script that has all the functions written in it. Or we can say include. I'll just put ... here. Include, and then the file name we want to include, and that will bring it in. However, well, before I get to that, they're interchangeable, completely interchangeable. I'll write that in different colors. It doesn't matter which one you want to use. They're completely interchangeable. The difference is require will throw an error, whereas include just throws a warning. We'll talk about error handling, exception handling next week. But in either case, we don't want the end user seeing an error or a warning. So either way, it needs to be addressed beforehand, right? It doesn't matter if the function returns an error when things go wrong, or if the function just gives us a warning when things go wrong. We need to fix it and address it before the user sees it anyway. At least put it in a try catch block so we get it, so that we have control over what the user sees, and make a nicely formatted version that isn't going to make the user panic when they go to our website. So either require or include. However, machines are not intelligent. And if we use a lot of functions from a library, and say require, it would do the same thing on the other one. When it runs the function the first time, it's going to go read that library into memory. Then when it gets to the next function stored in that library, it's going to read it into memory again. And again and again and again. Even if it's running the same function over and over and over again, machines don't, they're not intelligent. It's going to keep reading that library into memory. So a slightly better way to do it is to use require underscore once. And I'll put dot, dot, dot here, pass in the file name. So we require once and pass in that library we want. And then it remembers that it loaded it into memory, so it won't load it into memory over and over and over and over again. In the modern world, it's going to be a long time before we're out of memory, but we can. It's still a concern there sometimes. We can still bog down a computer. They've gotten much bigger and faster than they used to be, but there are still lots and lots of problems we could come up with that would grind a computer to a halt. So it is still, those things, efficiency is still an issue, just not as much as it used to be. And same thing for include. There's an include once, and we just pass in the library. And I usually I'll use this one in class. I'll be using require once, but if when you're thinking things through and putting your algorithms together, you prefer to use include instead of require, that is fine. Just whichever one feels like it makes more sense as you're putting it. The once is a little bit better. That just tells the computer to remember that it already loaded it in, which isn't going to fill up RAM on the RAM on the server by repeatedly loading the same library in over and over and over and over again. Because machines aren't intelligent, it won't even notice that it's doing that until it suddenly runs out of RAM to work with. Then once we get it in, then call at the appropriate place. Call at appropriate place. I might be writing too hard. I keep breaking the chalk. And I'm just going to do the call first. So I just abbreviated a generic one here. I'll call it function name. And when I do the other example here in just a moment, I'm going to give it the same name. And then pass in whatever arguments it expects. So like arg1, arg2, dot, dot, dot. We can keep passing in arguments. And when we define our functions, we set them up. If we need to take in values, we set up parameters that need to be filled, and then we can use those parameters in defining the function. And when we call the function, we send arguments to fill those parameters. Just some vocabulary terms that are probably going to show up on a quiz at some point. Make sure you remember that. Send arguments and accept parameters. Send arguments to fill parameters. Those vocab words will probably show up on a quiz or something at some point for you. So we call that, and over in the library where we defined it, and again, we don't have to do it in a separate library. We can do it in the file we're working in. But if we do it in the file we're working in, we can't use it anywhere except that project, right? Because we'd have to import that entire file, and then there's probably other stuff there that would cause problems when we import it. So the library is just PHP functions and objects, which we'll see next week. So we start with the keyword function. Which will probably be nice for those of y'all working or taking this class and client-side scripting, because JavaScript uses that same keyword. So function, we're going to define a function. Then we give it a name. I'll just use that function name thing again. And then we set up the parameters to be accepted. And we don't have to, if we don't need any outside data, we don't have to set parameters. Just if we need it, we go ahead and set things up for it. Param2 ... because we can keep going just however many we need. And I ran out of room. I'm going to erase the second parameter and just write the first one here. ... Then close the parentheses for that. Then our curly braces, and inside of our curly braces, any valid PHP code. We can put functions inside of other functions. In most cases, it gets a little bit confusing to do that, but in PHP, we can nest functions. That's something we can't. Other languages, we start to have a little bit of problems or can have difficulties with nested functions, but PHP doesn't have any trouble with it. We can create objects, which we will see next week, create classes right in the function, and then use an instance of that class right there in the function if we need it. Any valid PHP code can go inside a function. There's the only restrictions are the restrictions we have anywhere else in PHP. And important to note is, well, notice on the arguments, I wrote the $sign on there, like we're used to with variables. Our argument, same with parameters. Arguments and parameters, we treat like a variable. Essentially, it's a parameter is a local variable. It only exists through the scope of the function. And when we send stuff in, we're filling a variable, so that kind of counts as a variable as well. And the function name does not have a $sign. So no $sign on a function name, and no $sign when we call that function. So no $sign on the functions, but we do need $signs on the arguments and parameters. And when building functions, just a note, you just want to look for every possible generalization you can. Anything that can be generalized and filled with a parameter instead of a specific case. Use the parameters as much as possible because it increases that reusability aspect of it. I need to erase the whole board, I guess, because I need a bunch of room for a picture here. So I guess kind of getting into more computer science aspect-y stuff. Is it okay if I erase the board? I'll start with this half over here. But yeah, it's a big picture, so I need to erase the whole board. This has been here for a minute, so hopefully it's okay over here. Yeah, it's just, we tend to put them in other files in order to make it more reusable, which means we have to import it and either require or include, and it's better for them to make sure it only gets required or included once. And they're essentially interchangeable. So the only difference is whichever word makes more sense in your mind as you put your algorithms together. Yeah, so Then we just call the function when we need it, and no $sign on the function names when we call it or when we define it. So I was talking about passing arguments and filling parameters. Passing args and filling params. That's going to be the next little thing to consider. There are really three ways we can pass arguments. We can pass values in and out of a function, really in. We'll get to returns in a moment. But when we pass something in or when we expect to receive something, there's technically three ways, but one of them almost never gets done anymore. So I'm only going to talk about the two that we still use. And I'll draw those stack heap diagrams, which I've drawn a few times here. So representing what goes on in the CPU, we have the stack where we stack up all the instructions that we wrote for the computer to carry out, and then pop them off that stack one at a time as we carry them out. So this side is our code, and then we have Heap, which is the dynamically allocated memory, where we're actually storing stuff. So this is the RAM, the memory we have to work with. And in our stack now, we'll have a couple things. We'll have our main value, and I'm just going to write, maybe we have a variable X here in our main, the main function, the one that starts everything. And that refers to some block of memory. We've got a bunch of bits over there storing the data we actually want. And then we have our other function. I'm going to write func1, and it has a parameter that needs filled. So I'm just going to call that P. Obviously, we wouldn't want to use single letter things in our code anymore, but for writing on the board, it gets kind of messy if we use reasonable variable names on the board. So that's the situation we have. We need to get this value into here, and what goes on over on the other side. So I actually need two pictures here. So I'm going to draw an identical one, or, well, yeah, basically identical. Drawing it quickly so it's not an exact match, but so in the stack, and then over and we have RAM organized as a heap. So again, in our stack, first thing we put in the stack is the main function, and that has this variable X pointing to some block of bits over here in RAM that stores the actual data we want. And then, well, the next thing we push onto the stack is this function that is expecting a parameter, and it needs some data in order to run. So we need to get the data this references. So the arrow here is kind of important with words I'm getting ready to say. So the variable, the reference, and the actual data. They're three separate things. So we need to get the data that this variable references into that parameter. And there are two ways we can pass it, really three ways. The one that's never used anymore is by address. So we, maybe if this is bit 100, we could take and just say, use what's in bit 100 and just tell it what address that is stored at. that's not used much anymore. What we do use a lot is by value or by reference. I don't have much room. So when we pass by value, we're passing a copy of the data. If I use the red chalk, can you all see a difference here? Does the color stand out? I guess I could look at the video. I guess it kind of does. It's visible at least. Hopefully it stands out a little. So when we pass by value, what we do is make a copy of that. And then the parameter will refer to that copy. And when we pass by reference, I pointed out that in this picture we have the variable, the arrow is the reference, and then the bits over in RAM are the actual data. So passing by reference, we're actually passing that arrow up there. So it comes down and refers to the same data. And there are some big differences in usage on these, right? You should already be able to predict what's coming up next, because here, when we pass by value, we're working with a copy of the data, which means when we finish function one and pop it off the stack and then get back down to the main, well, that original data is still there. But when we pass by reference, we're referring to the same bits over in memory. So any changes that get made here, we finish running function one, and that data might have been changed along the way. We'll pop that off the stack and get back down to our main function. And the data that references is now different. So let's do a simple example. So, oops, I'm gonna write a very short function up here. So we have this function, I'll call it F1. That's a nice easy name to write on the board, and we expect the parameter to be filled. Actually, I'll go ahead and call it P so it matches what's wrote on the board. But again, in your code, you probably wouldn't want to, you want to give it better names than single letters. So what can we do with this? Let's triple the value. So P multiplication assignment by 3, which again is shorthand for P equals P times 3. And then we'll echo P. End of instruction. Might as well write the semicolons up there. So here's our function one that we need to pass some data into. Then over in our code, kind of left myself a little corner here to work in. Over in our code, we have some script, there's a bunch of stuff going on, and eventually we get down to that line where we have X. X starts at maybe 5. We have a 5 in there, and then we're going to pass it into that function. So we call that F1 function and pass in that value stored in X. And, well, I'll just write echo X. So after that function runs, what is X going to be? So, I don't think the purple will show up. I'll try yellow. So right now we have a 5 stored here, Should I write that in binary? You can do it in 4 bits, right? 1001 is stored there in both cases, whether we're passing by reference or by value. We have 1001. And we pass it into the function. So do this call, that points over here, get it in a 5. We use the multiplication assignment to triple it. So now we have 15.
And my brain's blowing up here. 1001. I got a 1, no 2s, 1 4, no 8s.
Oh, whoops. 0101.
You were blowing my mind there, Chris. I thought I'd forgotten everything Lloyd had taught me about binary.
Sorry. That's a common one. I probably should have remembered that. But yes, 0101. So that's our actual data. We pass it in, and at first that's what we put in here, right? 0101 gets passed in, but then we do some work with it. We reassign it. Often when I'm typing the code and thinking about the algorithm, I'll use that word, reassignment, instead of assignment like a normal equal sign. As I'm typing this, I'll think P is reassigned by ×3. I found that's useful in my mind. It fits here too, because we have a 5 and we're going to triple it. And 3 times 5 will be 15, right? Which 15 is easy, right, Joe? It's 1 less than the power of 2, which means it's all 1s.
Yep. I was going to say, I think you've maxed me out for the day, but yes.
Yeah, 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. Or I just remember if we have a number that's 1 less than the power of 2, it's going to be all 1s. So there we have all 1s. So that's what gets echoed back to the screen. We pop this off our stack and we come back down. But this line here, when we pass by value, that's going to print a 5 back out. Because we come back down here, we were only working with a copy of it. If we pass by reference, well, kind of the same thing of 0101, call our function. So we take this data, pass it in to fill that parameter, only we're not passing the block of bits, we're passing that arrow that points at where that block of bits starts. So here, when we hit this line, P is reassigned ×3, this data is what gets crossed off and replaced with all 1s. Then we echo back a 15, just like we did last time. But when we pop this off the stack and come back down to the main to do other stuff, then hit this echo line here, where we're going to echo back a 15 because we changed what was in that data. So it's important to know how your functions, how you are passing your data to the functions. Some languages restrict that. In particular, the 2 most popular are going to be Python or Java. C# is gaining on Java, but C# is modeled after Java, so they're almost identical. If you know one, you pretty much know the other. So I'm going to say Python and Java, and those are restricted. So Python only passes by value. For those who have had that class, actually, I filled in for Lloyd that day. Remember, if we need to change, we can access it. In Python, we can access it. But if we need to change it, we have to use that global keyword. The other day when I was filling in, we talked about that in the 140 class. We have to use that global keyword because Python only passes by value. So we have this situation that after our function runs and we get back, our original data is untouched. And that keyword global tells us to change it.
Wait a minute. does it make a difference? If part of it makes a difference on where you're echoing, if you're echoing inside the function or outside the function.
Well, this is after the function runs.
Oh, okay.
Like here, I echoed both of them, right? This one echoes 15 in either case because we passed in a 5, tripled it, then printed that out. But then over in our main, I guess I could have wrote that here. Over in our main, after that echo, we echo the original X back out. But passing by value, it would be back. It never changed. And passing by reference, we actually changed that data.
Okay, now I'm absolutely confused. I mean, I thought I understood by value and by reference. How do you know which way it's going?
So sometimes with language, so Python is always by value. And if we want to do this stuff here in Python, we have to do some extra things in the background. Java is always by reference, and that has to do with garbage collection. Both of those languages have very, very, very good garbage collection. Like we almost never worry about RAM ourselves because both of them are amazing. And to keep that garbage collection optimized, the language restricts how we can pass our data in. Garbage collection being like this block here. After this function runs, these bits are still filled up in memory. So we need to come back and clear those out of memory and clean it up afterwards. So that's where this stuff comes in handy. So some languages restrict it, but in PHP, we have control over whether we want to pass by value or by reference. So I didn't put the symbol in here yet. The default is to pass by value. So we are doing this. So the thing to remember is you have your main script running, and when you call a function, you're going to pass some stuff in, and you might change it. You do some work with it, right? Concatenate strings, do some math on numbers.
Like when we're cranking out our list of what kinds of cupcakes did they order?
Yeah.
Concatenate our cupcake string or whatever we want to call the dumb thing.
Yeah.
I can see that going into a function.
It gets changed along the way. So then after that function runs and we go back to our main, the main script or the main function that is calling all our other functions, has the data changed or not? So
well, let's see. In that case, we do want it to change because the function is actually concatenating the string. And we would like to see the concatenated string.
Yes.
So that means we would want to do it by reference and not by value.
Exactly. And to pass by reference, we put an ampersand right before our parameter. I always have trouble drawing those. So ampersand $sign parameter. And that passes by reference. So I'll write that really big here on the board. Ampersand to pass by reference, and the default is going to pass by value. So do you need that data when you get back? That's the question. Like Joe's excellent example there. A function that can concatenate our string. Well, we don't want to get back to the pieces of the string after our function. We want that string we put together. Does that make sense? So we actually have to choose how we are passing our values. How we are passing our arguments or filling our parameters. And again, the difference between arguments and parameters is probably going to show up in a multiple choice quiz in every programming class you take. So that is an important vocab one. The last note I have here, we have not been doing this in class, and if you do set our book never even mentions it, but if you do decide to use PHP in strict mode, you just have to remember that the functions need a return type. So there's no return here, but if we wrote a function that sends back that returns an integer after it does all the calculations, we would want to specify function integer because it's returning an integer, and then all this stuff. And same thing, if you said it's a strict type, you have to say what type your parameter is going to be. Say that a certain parameter is going to be an integer and another one's going to be a string and all that. We aren't really doing strictly typed stuff in this class, and the book never even our book doesn't even mention it, but it is available because we're working in modified C++, and C++ is a strictly typed language. So we can undo that modification and get back those advantages, which is strictly typed languages are much, much faster and more efficient with memory usage. So sometimes it's good to use those. Then in my notes, I kind of went into recursion a little, but recursion isn't on our required list of things to do, so we'll cover that late. We'll come back and cover that later if time allows. Recursion is when we have a function call itself. So in most of our programming languages, we have loops. It's a nice way to reiterate things, keep things happening over and over again. But machines don't naturally do loops. What machines naturally do is feedback. The output becomes the input. I think everybody's experienced audio feedback, where we do something. In the case of audio feedback, we like talking to a microphone, the sound gets amplified and it goes right back into that microphone to get amplified again and again and again and again, very, very quickly because it's a machine. And before long, it just fills the room, but the output becomes the input. That is what machines naturally have in order to create repetitive or reiterative structures. And we do that with functions. So the functions have to call themselves, and there's certain criteria that have to be met, which most things don't meet those criteria, and we have to remodel our problem into something that can develop into an algorithm. So it's like we can't just remodel our algorithm. We have to remodel our problem until we can get so that we can create an algorithm that can solve the modified version of the problem. And recursion gets really complicated. That's why most programming languages have loops built in, because it's much, much easier to work with. And we have loops. Recursion's not on our list of the core list of things to learn for this class. So I'll come back and cover that if we have time. But we have loops in PHP, so we can use loops and not have to worry about all the headache with recursion. But if time allows, we'll come back and look at that. Does anybody have questions about the general syntax and the concepts there? Passing by value versus passing by reference. And otherwise, I guess it's mostly a syntax thing.
I'm going to ask this question real quick.
Yeah.
What kind of things would I want to pass by value and not by reference? Because I can see that I guess if I was putting out something totally, if I was returning something totally different, rather a different value, like if I'm doing something and if my num that I'm putting in, or $num, is a number I put in the function, and my return is quotient, like if I'm dividing or then I could do it by value because I'm not expecting to change what I'm putting in.
Yes, exactly.
So did I just answer my own question?
Yeah, it kind of sounds like you did. So what that question is answered by what happens afterwards. Right? So think about our stacks. We stack our functions up, then run through them, pop them off the stack one at a time. So we're going to get back down to that function that called this one. So eventually this is going to run and we'll be back down here. So the choice of whether you want value or reference depends on what happens after you run that function. Like this tripled the number. So maybe the next line of code you want to know what 4 times that number is. And then 5 times, there's just something systematic like that, right? In that case, we want to get back to the original number so that we can keep checking that.
So if I want the same dish on my stack by the time I get down to it, like if the 4th dish in my stack is a red dish, if I still expect to see the same red dish, I'm going to do it by value. But if I expect to see a different dish in that position of the stack now, I'll do it by
exactly
reference.
Yes. Yeah. Yeah. It takes a little bit of practice, and that the decision of when to use really depends on what happens afterwards. The only other time it either depends on what happens afterwards or how you set up your memory management. Because I pointed out Python only goes by value and Java only goes by reference because of the garbage collection built into those languages. And garbage cleaning up, taking control of RAM and cleaning that up when we're done can be kind of a headache.
So if I can only go by value, it might be difficult for a function to concatenate for me, because I'll never see a concatenated thing unless I call it something else.
Yes.
If I manage to
actually return the value afterwards and bring it back and then replace what you send in and stuff like that. We will see return, because we can also, 2 other types, I guess skipped over it in my notes. There are 2 types of functions. We have void functions and return functions. Void functions just do stuff. Like this one I wrote here is a void function. It takes in something, it does some math, it does an echo, and then it's done. So the caller doesn't, when it gets back here, there's nothing coming back to store a variable or use elsewhere. Our key, if we want to return a value after we do all our processing in the function, the keyword is return. That's fairly standard in programming languages. We'll see the syntax in just a moment. In that case, there's something coming back, like maybe instead of echoing this, we just put return P. In that case, instead of throwing it on the screen with an echo, we're sending that back to whatever called the function. So our function would have to put that somewhere, like x3, a variable x3 or something. So 3 times as much as what x is. And if we get a return, we need to put it somewhere or do something with it. If we just have a void function, that means it just does stuff and there's nothing coming back afterwards.
Okay, now if I've got a return function, if to go to the function, if I said that a particular variable, a new variable, is going to be that function, with that argument passed, when it's all done, whatever I've defined that as becomes that result that is returned. So I've already defined what the return is.
Yes.
Okay.
So that would answer your last question a minute ago about the concatenating strings with by value. So you can return it and then have the result.
But have it called something else, so that okay. Yeah,
definitely call it something else. That way the original data is still accessible if you need it. Any questions about the conceptual stuff? So let's see, 206.
I think I need a cup. I think I need a drink.
That's what I was thinking.
Not alcohol, but a drink of something.
I was like, okay, some coffee. I was thinking, we'd only be a couple lines into an example by the time we should really be taking a break. So let's go ahead and take 10 minutes now. Does that sound good to everybody? And then we'll do the example. And it's an active subject. We learn a lot better by typing it up than listening to me talk about it.
That sounds good. Thank you.
All right, so we'll be back here at 2:18 and then look at the example.